This is a project that has been going on for about 3 years. So what you're looking at is farmland that's been in under wheat production, so for grain, for over 5 years. And about 3 years ago, these 3 wheat sections, or strips if you want to call them that, were broken out into different tillage practices. So right here in front of where we're standing is our conventionally tilled wheat strip. And then to my left we have a no-till wheat strip, and then further down we have a vertical till wheat strip. And so our question was simple when we started it, how do tillage practices affect both production, moisture, compaction of the soil? This year we kind of wanted to expand that out, broaden our horizons a little bit, and think about how we could include cover crops and maybe alternative forages in this rotation instead of conventional grain production. As many of you are aware, in this part of the state we don't really produce conventional grain, so we're going to look at maybe some annual forages and kind of rotate between a diverse cover crop mix and some annual forage options in the coming years. But the key questions I think here are, first of all, how does tillage interact with cover crops and their effect on different soil parameters? And then the second thing that we were looking at was the diversity and the cost of a seed mix. And so when I did my master's research, we recently finished it up, we used a seed mix that came in around $35 an acre, seeded at 34 pounds per acre on dry land. And so that's a pretty pricey mix, and we found in that study that cover crops did not pay. We were actually losing money by cover cropping. And so I guess the question you could ask is, why is that a concern? If you're trying to build your soils primarily and you don't care about the cost and what that does in your operation, then you maybe can think about upping the cost of your mix or the diversity of your mix. But if at the end of the day, if your bottom line is you have to make this work financially, what can we change to make this profitable? And so what you're going to look at here as you walk through, there'll be 3 different mixes. There's a high diversity mix with 13 species in it that again comes in at about 34 pounds per acre and close to $35 per acre. And then there's 2 mixes I worked with Kate to bring down to around $20 an acre. And they have between 6 and 8 species in them, depending on which one they were. And then there's some different labels on them. You can kind of ignore that this year probably, because it's been dry enough for the last couple months that we're not going to probably hay any one of these mixes. But as you read through those signs, there's a grazing mix, a haying mix, and then that diversity mix. Basically that's going to determine how we manage that cover crop. The diverse mix we're probably not going to graze. We're going to just roll that into the soil and leave all that residue there and see what that does. And we're going to compare it to that mix where we graze it and include livestock, and then their action, both in terms of trampling forage and then the things that they excrete and leave behind, and what that does to soil activity. And then we have the haying mix, so that's going to kind of represent where we go and remove almost all of that residue and leave more of a stubble like what you would see in this wheat fallow. And so those are just some different questions we have. I don't have any data on any of this yet, but that's something we'll be collecting and looking for in the future. What I wanted to do today is just walk through each of these wheat strips, and we're going to take a shovel and flip through some of that soil, and I want you to see the difference in how the soil looks under a conventionally managed system, a no-till managed system, and a vertically tilled managed system. And we can talk about the different types of equipment that we used in this if you're interested. And then especially in that vertically tilled system, that's kind of a gray area in terms of what all that involves, I guess. But it's an interesting system and has some interesting tillage tools that I think have showed some promise in what we've seen here, but maybe still have some of the challenges associated with a conventional system. So we're going to go ahead and just walk out there and start flipping soil, if that sounds good. And then if you have questions, we can talk about it as we go along. So I'll start in the fallow, and then we can just kind of walk into the crops too. So. And forgive me if this looks really bad to dig through, because it's really hard. So kind of like Caitlin was talking about earlier, when she was able to flake off that soil, you can see that plow pan. You can kind of see some of that happening here. Basically at the depth where we have the disc run through. it's pretty chunky up above that. And then below that, you kind of start to get into some moisture again. But you can see the effect of just consistently tilling right at that same depth every year, year after year. We've got a really hard layer, really chunky on top. And so I guess we can look at the other one too, under vegetation
What's the
too.
difference between that one and this one? That one is greener.
Oh, in terms of the cover crop mixes?
Or something.
Yeah, so they are a different mix.
Oh, okay.
And typically because of the angle of the field, the moisture is better as we get further into the field. So yeah, these first plots are pretty dry. I'm not sure. It's kind of similar, honestly, with the cover crops. This is probably a bad plot to look in because the vegetation is not providing all that much cover. And just to add some context, I seeded these the 1st of June, right around that first week of June. That's later than I normally seed a dryland cover crop. Typically I try and get them in pretty close to as early as I can. And I've had a lot better luck, even with warm season species in the mix, getting them to grow and produce. This is the first time I've had them in that late on dryland, and you can see the effect in terms of the lack of production. Yeah, we're pretty chunky still. You can see a layer right there, kind of like you could on that sample too.
If you turn around here, you can still see these roots growing down here, and that'll be something for you to watch on your own place too. Is watch how deep your roots grow and see if that changes over time. And then this, like he's saying, this, like Tyler's saying, this really blocky structure, and how big those pieces are as they break apart.
Yeah,
and how hard it would be if you were a little tiny plant root. How unhospitable this environment would be for you.
I mean, it takes so much moisture to get this chunky soil to a place where you can farm it effectively. It's terrible. But you'll be pretty interested, I think, to see what it looks like when we move to the no-till and vertical till strip too. Same cover crop mixes as you're seeing here, and we'll have a completely different result, I think. So.
The other measurement we use a lot in soil is bulk density, so you're looking at the weight per unit volume. And so, of course, the less air there is in your soil, the more dense it is, and just the weight of the soil. It's massive, is the actual scientific term for it also, is it's just a massive soil. And so there's just no airspace, there's no oxygen, those microbes that need oxygen are not thriving, and the plants are struggling. And you can see it here too, see that vertical or horizontal sort of flaking there.
Yeah. Played it off. But yeah, and the other thing to point out too when we talk about mixes, one of the discussions earlier was that you try and get a group of plants in these cover crop mixes that have different rooting depths and different rooting structures so that it kind of covers a broader depth and more coverage of your soil in general. And that's something that this mix probably isn't designed to do super well, because if I remember right, this is the haying mix, and so it has to be able to go through, you know, your swather and stuff. Is this the grazing mix? Oh, right.
That's grazing.
Yeah, and so I guess that's the other thing you're seeing is that the turnips and radishes and other things that were in this mix that would have provided that deep rooting structure didn't really make it past the first 2 weeks when they emerged. That's been a pretty consistent problem we've had on this place with dryland and some of those better cover crops for addressing compaction. It's really hard to get them to grow and have enough moisture. So.
What would have been in this mix?
Spring forage peas, sorghum, Sudan grass, sun hemp, Laredo soybean, nitro radish, sunflower, and annual ryegrass.
Yeah. And I will say, so the annual ryegrass, early on, it's wilted pretty bad now, but it did get up and provide pretty good cover pretty quickly. And as a result, the presence of weeds in this plot is not as bad as in some other circumstances that you'll see throughout the field. Like in that plot to your right, it was a little bit delayed in terms of germinating and then emerging, and there's quite a bit of jointed goat grass in there, so it didn't fight off the weeds quite as good as this annual ryegrass was able to do. Now that it's shriveled and kind of dying, it's not providing all that great a cover. But anyway, I guess the idea with the cover crop mixes themselves is we're just trying to play with things and find things that work really good on dry land. And I would say we're not there yet. But I think with that we can move into the no-till strip if we want to.